Good evening. Welcome to the fourth lecture in the 2020-2021 Railway Division Northeastern Centre programme. Tonight we're co-hosting with the Southeastern Centre of the Railway Division. We've got a large audience this evening, which is very, very welcome. So welcome to you all. I'm Louise Shaw. I'm the chair of the Northeastern Centre. Tonight I'm co-hosting with my colleague Toby Johnson, who is chairman of the Southeastern Centre. So as normal, we've got some parish notices before we start, then the lecture followed by plenty of time for questions and answers. We also have an informal after party, if you like, being hosted on Zoom to enable people to interact a great deal more than you can through this format. So details of that are to follow. In the meantime, we have some parish notices about the upcoming centre programme and the upcoming Railway Division events, which you can see on this slide. Thursday evening this week, Nick Donovan is talking about performance management to the Scottish Centre, and then we go through into December with a number of more socially focused lectures, a film evening for the North East Centre, and then a webinar on the technical matters of wheel-rail interface tripology. So there's plenty to choose from, and then we go through into January, which the first presentation on that list is Chinese locomotive, and then on through to the annual luncheon with a variety of events in between January and March. I'm promoting the annual luncheon to you now. It is virtual for the first time ever next year. All the funds raised will be going to charity. You can host your tables in the way you would if you were hosting a real table, or you can book an individual place and you will be looked after by somebody in the Railway Division and put together with other individual guests. You can provide your own dinner, or own lunch rather, so you can choose what you eat, but we're hoping that it will be as social an event as we can possibly make it under the circumstances, and we will do our best to ensure that the speeches are as entertaining as possible, and if you wish to run a sweepstake on the chairman's speech, you can do so, but that's up to you whether you choose to do so or not. Something else I should also draw your attention to is that we are presently in the middle of a series of rail technical strategy webinars being run by RSSB. So if you wish to hear the remaining 3 of those, they are advertised on RSSB's events page. You can also look back on webinars that have already happened. The first 2 were Thursday last week and today. So I commend those to you, and there's the opportunity to make a contribution as well to the development of the rail technical strategy. Next South East Centre lecture is on the deep tube trains for London, which will be built in Goole in the North East. So it's close to our home as well, which is good news. And I'm sure the South Eastern Centre are looking forward to hosting Mark Foster to talk about that. If you do wish to go to any of the upcoming Northeastern Centre lectures, you should be able to find details on the IMechE's Near You page, along with all of the other communication media that we have available to us, which you can see listed on this slide. We have a reservations system, so you can book in for your place at any events as early as you like, right through to the end of the programme now, and I will post that link into the questions box so everybody can cut and paste that and access all of the Railway North East Centre events which are coming up. If you'd like to be added to our mailing list, you can see the email address at the bottom of that list there. Just drop us an email, let us know who you are, and we'll put you into the right list. So we'll come to tonight's webinar, and First of all, for people who have not yet used Workcast as a platform, it's, in my experience, quite a good one to use. On the top right-hand side, you should see a white arrow. Click on that, and a series of little bars will come out, and one of which is the attendee questions. Please type in your questions for tonight's lecture in that box, and Toby and I will keep an eye on them and make sure that they're grouped together at the end of this evening and put to David Shirres, our lecturer. If you've got any technical queries for Fiona Wong, who's looking after us from IMechE headquarters, please also put them in there and Fiona will deal with them directly with you. If you wish to adjust your screen size, at the bottom right-hand side of the slide, you should see a little double-headed arrow. Click and drag on that, and it'll resize your screen for you. David, our speaker this evening, has kindly agreed to the lecture being recorded, so it will go on to the IMechE's webinar hub at some point in the near future. So if you do wish to look back at something, listen to answer a question, it will be available to do so. It'll be a YouTube type video from start to finish that you can scoot through to whatever point you wish to do. And as I said, we will have a less formal engagement afterwards on Zoom, which will not be recorded. So, time for me to introduce our lecturer this evening, David Shirres. David is the current editor of Rail Engineer, for whom he's written over 200 articles and been the editor since 2016. He retired from Network Rail after a long railway career in a variety of roles around traction and rolling stock depots, safety, training and infrastructure project management. So quite a blend of different areas of work and quite a balance as well. Since he retired, he's also been the chair and the secretary of the Railway Division Scottish Centre. And he's also very active in giving lectures for other centres as well. So we're grateful to David for giving up his time tonight. His topic tonight is called the Judicious Mix for Rail Decarbonisation. We all know it's a very hot topic and things seem to keep moving on week by week at the moment. So we're looking forward to what David has got to say. So without further ado, I'll hand you over to David, and please keep putting your questions in. You don't have to wait, just put them in whenever you get to them. Over to you, David.
Thank you, Louise, and good evening, everybody, and thanks for coming along tonight. As Louise has said, I've written quite a few articles for Rail Engineer, and in 2017 I was lucky enough to see the blue train on the top right there, which is Alstom's hydrogen train. And since then I've got quite involved and interested in the application of trains like that, but the whole decarbonisation story. And the presentation I'm going to give tonight builds on a lot of the work that we've done in Rail Engineer on that. But before we get started, a question to ask you. If I push the button, I'll get the next slide. There we go. Could I ask you to think about other railways? Compared with other railways, do you think that the UK has got a reasonable carbon emission record? It's not particularly interactive process, this webcast thing. So what I could ask you to do is, where it says ask a question, just ask a question, but just say yes or no. The answer will come in about 11 slides time, and by then, Louise and Toby, we should have a measure of what the audience view is on that subject. And the other thing I would like to mention before we start is that, of course, we are living in extraordinary times and very, very difficult times. And what that means as far as the rail industry is concerned is that currently our carbon emissions performance in terms of CO2 per passenger kilometre is really pretty poor. All the information I'm using in this presentation dates to when the railways were full, pre-COVID, and I think all the conclusions that I'm drawing still remain valid, because the climate change issue is a very long-term thing, and we've got to look towards the long term. So that's the introduction. Story I'm going to tell really starts in, 2017 with the cancellation of various electrification schemes. Government was quite rightly concerned at, frankly, the quite unacceptable cost overruns. As a result, the Transport Minister at the time, Chris Grayling, came to the view that the problem was electrification rather than the delivery of it. And having been to Intertrans recently and seen a hydrogen train, he was convinced that we didn't need electrification, we just needed battery and hydrogen trains. And some of his knowledge and some of the things he said were frankly inaccurate. For example, there didn't seem to be a realization that to get a decent train timetable, you need trains with fast acceleration. It wasn't just about trains running faster. So, for example, a comment he made to the House of Commons about trains between Glasgow and, Swansea and Cardiff not needing electric trains because diesel trains would just be as fast was just frankly untrue. We then move on to, in February 18, Joe Johnson, rail minister at the time, made his quite well-known statement about taking diesel-only trains off the track. He referred to alternate fuel trains, and he asked for the railway to provide a vision as to how it will decarbonise. But the government kind of told the railway what vision they expected. Came across a recent RSSB report, which says, as you can read there, that the government made it quite clear that its intention was to decarbonise rail and use innovative solutions rather than relying on electrification. So the result of that was an interesting task force was formed to write a report, and here it is. If you've got a magnifying glass, all 68 pages of it, and on page 5, it concluded that a judicious mix of traction technologies was required, which really is the title of my presentation. However, if you got as far as page 34 of that report, you'll see it mentions the need for likely electrification of 4,250 route kilometres, which is a huge electrification programme, but you've really got to go quite far into the report. And to be fair on the authors of that report, they had a difficult situation because essentially they had to respond to the guidance they'd been got from the government, and I don't envy them dealing with the politics of that. But nevertheless, some of the various reports and things that have come out have not actually been as clear in terms of what's needed. But one of the things that that report did recommend was the production of a further report, the Traction Decarbonisation Network Strategy. And that gave quite a clear vision. It did quite a detailed interim programme business case, which looked at not just emissions reductions, but many other benefits. It considered 5 pathways, 5 options for different rates of deliveries. It considered a range of costs, ranging from the costs that were experienced on the Great Western Scheme to the the sort of costs that are happening in projects in Scotland and the like. And it came up with, depending on the pathway and depending on the range of costs, net present value ranging between minus 2.5 billion and plus 1.6 billion, all of which absolutely emphasises the need for cost-effective delivery of electrification. And it came up with a requirement expressed in single track kilometres, as you can see, for a very large-scale electrification scheme with some use of battery and hydrogen traction. And that was quite a definitive report. It is now with the government for consideration before it is finalised. The point about cost-effective electrification is crucial, and the industry has to convince the government that it can actually deliver on that. A lot of good work is being done. The Railway Industry Association produced an excellent report on this. They made the point, and that graph on the chart shows that our electrification schemes are so stop-start, especially in the last couple of years, whereas in Germany, they just quietly get on with it and deliver it on a steady rate with experienced teams who know what they're doing and continuously just churn out electrification. We stop-start, have to build up teams. Clearly, that's a hugely inefficient way of doing things. But there's lots of really good initiatives taking place now, as well as the rail industry report, to look at how costs can be reduced, and some quite clever initiatives on avoiding bridge reconstructions. The other point to note is, let's look at maybe lessons from the past. In 2009, Network Rail produced a route utilisation study which showed all the benefits of electrification. And a bit earlier than that, and I think this is an interesting point, there was a letter written from the chairman of the Association of Train Operating Companies, Adrian Tutor, and Ian Coucher from Network Rail. It was a 3-page letter, and in it you can read what it says on the screen about it's not very helpful to have mini power plants running around. It's better just to have one big power station. But that 3-page letter seems sufficient at the time to convince the government to actually back electrification. Sadly, of course, it all went wrong, as we previously referred to. So that letter raises some points. One of the things that I wrote for a forthcoming article, there are some hugely powerful reasons why one should electrify. I appreciate I am probably teaching lots of grannies to suck eggs by putting that slide up, because there's not a lot that's probably news to many of the audience, but the fact that you have trains that don't need to carry their own power on board, that can actually suck up energy on the move, that are not limited by the onboard power. There are so many basic fundamentals there that are actually realities that innovation cannot change. But the problem is, as we will see, that reality has not perhaps been communicated as effectively as Ian Coucher and Adrian Tutor did 13 years ago. And I think it's quite possible to put the case for electrification, the actual practicalities of it, in a relatively short space. Moving on. Right, we come to our question. Could Louise and Toby perhaps tell me what the response was from the audience? Can anybody tell me, give me an answer, or should I move on?
Hi David, it's Toby here. Yeah, we had a great response to your question. Some of the answers are still coming in, but I think we've got a roughly a 60 to 40 split no to yes.
Okay, well, I have to say the no's are right. I was on a webinar with Russian Railways recently where they put some international comparisons up, and I actually put the UK figures on, and the result was this graph, which shows that the UK's carbon emission comparisons shows it to be pretty much the worst railway in the world for freight and for passenger emissions. And the reason for that, if you look at energy use, is that when you look at the percentage of traction energy that is diesel as opposed to electric, 95% of our freight is diesel powered. About 50% of our passenger services are diesel powered. And clearly, I mean, I've read some stuff that is claiming that the UK is world beating in rail decarbonisation. It is just not, and the only way that rail is going to catch up is to implement the recommendations of the traction network decarbonisation strategy to get a decent amount of electrification in the system. I found that I was quite disappointed actually when I actually put that together. I was quite surprised because, as we know, pre-COVID, Britain's trains are actually pretty full and heavily utilised. But despite that, we still have such a poor emissions record. And I find that quite a powerful message. I mean, Britain's railways has certainly got a good record compared with other modes of transport, but compared with other railways, there's clearly lessons to be learnt. And I believe that that's a graph that should be circulated a bit more widely. Excuse me. And one of the things I talked earlier about politicians' perception, the Transport Select Committee was quite interesting last week. It was all sceptical. I put one in there. I'm a great fan of electrification. There were a few people who said that, but there were a number of politicians on that panel who seemed to think that hydrogen is just around the corner, that essentially echoing the Grayling view that alternative tractions can do the business, when in fact they simply can't. And that led to a headline in the Daily Telegraph the following day about rush to electrify, because how do we know that electrification is the right technology, what's coming along, when in fact, of course, electric trains are future-proof because they can use any traction that's actually being generated. Interesting that there was someone saying, well, how can we trust the industry to deliver because of the previous high cost of electrification? And that's quite a difficult thing for the industry to retain trust. And maybe what we need, and it's happened in Scotland, but maybe it needs to happen in England, is that some more ongoing programs being delivered at low cost, although I understand the later Great Western Electrification and Middle and Main Line has been delivered at quite a reasonable cost. One of the questions asked at the Transport Select Committee is, why is there a different approach in Scotland? Now, as some of you may know, I'm speaking to you from Scotland, and the reason to that question, the answer to that question is this. Within Transport Scotland, which is effectively the Scottish equivalent of the DFT, there are railway professionals who just know that their railway will serve the people of Scotland best if it's electrified, because there are so many benefits. It's quite interesting. We had one scheme in Scotland that went really quite badly, but the response in Scotland was, well, what went wrong and what can we do to make sure it goes right in future, which wasn't quite the approach in England. And Transport Scotland have explained electrification to their ministers and successfully convinced them to invest what are scarce funds, which is true at this time. The result is that Scotland now has a rail decarbonisation action plan, which calls for it to essentially electrify virtually all the network except for the rural lines. And it is quite a contrast, and there was no need for any great lengthy reports and such like to get to that situation. I find that really an interesting, a very interesting contrast. One of the things, the arguments that Transport Scotland made, and it's certainly an argument that the DFT has made in its decarbonisation documents, is that perhaps modal shift is rail's biggest contribution to decarbonisation. And playing around with some spreadsheets there, I can give you an example of that. You could see, I don't know if my pointer's showing there, but currently rail about 2.5 million tonnes of CO2. If you consider a situation where there's a 5% passenger shift from road, 25% from air, that would actually change the traffic on the rail by make it 145% of what it is or was in 2014. The result of that is actually a 2.8 million tonnes carbon saving compared with rail's 2.5 million tonnes emissions. And if you make the same consideration for freight, a 5% modal shift to rail from freight would save 1.8 million tonnes. So add those two together, that's 4.6 million tonnes, which is actually pretty much twice rail's current emissions. So that shows potentially the huge contribution that rail can make. But it can only do that if it offers an attractive service. And the Sparks effect is well known. trains that can electrify, freight trains that can actually travel at a reasonable speed on main lines because they're being powered by electric trains. All that, electrification has got a huge contribution to that aspect as well. So, having talked about the judicious mix, the first part of the answer is essentially lots of electrification. That's what Network Rail's traction network decarbonisation studies come up with. That's what the case has just been presented here. What's quite interesting is what you do with the other 20% or whatever it is, and to a certain extent, that's the bit that seems to generate most of the discussion. How many hydrogen trains, how many battery trains should we have, how many bi-mode trains should we have? But before considering that, I'd like to go into the bigger picture. The big picture is, I said earlier, that rail's quite a low emission from the total picture. It's only about 2 million tonnes. Transport is a very big chunk, but we've got industry, we've got buildings, we've got lots of other issues that the UK's got to deal with, and where does rail fit into that? And just to recap, UK actually, in many ways, is world leading. The Climate Change Act, which actually gives the government a legal obligation to decarbonise, was recently amended so that instead of a benchmark of 80% reduction of emissions from 1990, it would be 100%. So we need to get to net zero by 2050. That is actually a legal obligation on the government. And if we look at progress on that, looking at the graph top left there, we're doing reasonably well. But when you actually look at what's happened to achieve that, there's been quite a few savings in industry, and I suspect that's down to industry activity. The big saving is in power. The greening of the grid has been huge, mainly because we've stopped burning coal. That graph there shows how coal generation has dramatically dropped since 2012 there. Burning lots more gas, which hasn't got quite the same CO2 emissions as coal, and a lot more renewables. So power is a real benefit, and it's because that's been reduced, it's meant that our electric trains have been actually able to see the benefit of that. That's a chart from the final report, the Decarbonisation taskforce, which shows how rail's emissions have gone down. It also shows how in passenger, but freight emissions have kind of stayed the same. And the reason for that, of course, is the people who should take credit for that is not so much the railway, but the national grid. We've done some things, like we've got new trains, we've done some electrification, but almost all that reduction in emissions is due to the railway being able to take advantage of the national grid because it's got electric trains. And surprisingly, that's not actually mentioned on that chart. Perhaps it should have been. One of the things which we looked at in Rail Engineer was the Committee for Climate Change's Net Zero report, which personally I found quite a bit of a revelation because we live in a crowded island. We rely on energy and transport. You could say the answer is to go and live on a farm somewhere and be self-sufficient and such like, but somehow we need to get to net zero and keep our economy going. And that CCC Net Zero report explained the approaches that could be used using existing technologies and processes to actually achieve that, albeit with some significant investment. But and we summarise that in Rail Engineer if anybody wants to look at it. The problem being is that with a lot of these things, it's a very hefty, long report, but it's worth getting an understanding of what that actually is about. And one of the things it came to is essentially the need to electrify everything, and that's not talking about railways. We in the modern world are utterly dependent on fossil fuels, and if we're going to get to net zero, we've got to wean ourselves off them. and electricity is the only alternative to actually transport and distribute power to where it's actually needed, albeit to fixed locations. And electric trains are probably the only form of transport that can use that on the move. And to give an idea of the scale of the problem, I think this is quite a fascinating diagram, but currently we use 55 million tonnes worth of oil equivalent for transport. Electricity production is 30 million tonnes. So as well as all the things that we use electricity for, whatever we power our transport is, we're going to have to massively expand our electricity production if we're going to get to net zero. And the CCC report explains that. That's the current situation, and that's what's intended for 2050, massive expansion in renewables. The interesting thing on that graph is what you use for baseload, which is nuclear, biofuels with carbon capture, and fossil fuels with carbon capture and storage. And hydrogen is seen to be a big part of the mix, primarily in central heating systems, putting hydrogen into domestic boilers and such like, but some of it for transport. And you'll see on there, and this is where the synergies fit in with other sectors. For net zero, the CC Climate Change report considers that 22 terawatt hours of hydrogen is needed for HGVs, 3 for buses, and only 0.3 for trains. So we're a bit player in this as far as they're concerned. HGVs, batteries do not cut it for HGVs, and hydrogen is very much being looked at a solution for HGVs. So that gives a bit of a background, which I think needs to be considered before we start looking at the industry itself. So looking at the various options that we've got, we have bimode trains, a very clever and well-packaged piece of engineering, which allow trains to travel on and off the wires. They have carbon pros and cons. Certainly, running an Azuma between London and Inverness saves about 33% in carbon emissions compared with the HSTs they replace, because they're not running under diesel power all the way. And things like bimode trains give traction flexibility that facilitates a rolling program of electrification. But on the other hand, each coach, there are 8% of the weight of the train is the power packs for the diesel traction. So that's not something that you should be using for too long. And with diesel engines, clearly they can't be part of a net zero railway. Let's talk a bit about hydrogen. Very topical, and certainly it has its role, but it's definitely got its limitations. And its limitations are basically around the laws of physics and chemistry and need to be understood. And for some reason, as I say, we don't seem to have communicated the fact that there are fundamental physical limitations associated with hydrogen that innovation cannot overcome. I first saw a hydrogen train in 2012 at the institution's Railway Challenge, run by a 1 kilowatt fuel cell. And if somebody would have told me that 5 years later I would have seen a full-size version, I wouldn't have believed it, but there it is. And there has been a massive development in fuel cells, certainly in the first part of this century, with the result that Alstom now have got a train in service. It can be regarded pretty much as a mature technology. It's a battery hybrid, because fuel cells are fairly constant, need a fairly constant output. And the really clever and perhaps most difficult bit is integrating that power source into the traction batteries and the braking, so you get the best optimum use of the power. It's got reasonable acceleration. It's got a range of about 1,000 kilometers. It stores its hydrogen tanks on the roof, as you can see. And in January 19, Alstom announced a concept for hydrogen breeze, which is essentially using the island technology on UK rail. As I said, one of the issues, a fundamental issue, is one of energy density. Diesel is a remarkably efficient way of storing energy, and if we're going to do the same with hydrogen and with batteries, then we need a much more space. I put a little table up there to show comparisons. Put uranium on there. If anybody can invent a safe atomic powered train, then we've cracked it, but I can't quite see that happening. Hydrogen has got about seven times the volume of hydrogen for the same range, and about 15 times for batteries. That means that it is possible for hydrogen to actually achieve a reasonable range. So even with its limitations, it can achieve a reasonable range, but not as well as needing the extra storage space, for which the UK loading gauge is a problem, and that's why on the breeze concept, the hydrogen's got to be stored inside the coach. The overall efficiency is an issue. If you generate hydrogen from electricity by electrolysis, you're going to lose about 30% of the energy. If you're going to store it at 350 bar, you've got losing another 6%, and you've got your fuel cell efficiency. So, roughly speaking, to get a kilowatt of power at the wheel, you need about 3 kilowatts of power. Having said that, one of the great things about hydrogen is that you can actually make the hydrogen overnight using surplus overnight wind power. So it does provide options for energy balancing. And if we actually consider how we're going to produce that hydrogen, let me take you to the Aberdeen Council's depot in Kitty Brewster, which hosted the busiest hydrogen fueling station in Europe, because until recently, hydrogen had the biggest fleet of hydrogen buses. Sorry, Aberdeen had the biggest fleet of hydrogen buses in Europe, and that ran as a pilot scheme for about 5 years, and they actually generated their own hydrogen on site. And to do that, it cost about £1 million for this hydrogen plant. The electrolyzers were in 40-foot containers. It was kind of a spare space at the back of their yard, so it didn't have a large footprint, and it required a 1 megawatt electricity supply. Very roughly speaking, a hydrogen train requires about 10 times the fuel of a hydrogen bus. The technology is a mature technology. It's scalable, so you would need 10 times the land and 10 times the electricity supply to be able for a depot strategically located to actually supply hydrogen for a fleet. Interesting that their conclusion was that the cost of hydrogen buses, total ownership cost of everything, was comparable with battery buses, but much more than diesel. And I suppose that's not surprising, because as I say, diesel is a very, very effective way of storing energy, and we're trying to replace that with a zero carbon alternative. So the fuel station in Aberdeen gives an indication of what's needed to produce hydrogen. And that's hydrogen. And batteries now, I mean, batteries are an increasingly known technology, and certainly have their application, and certainly in the transition they do. A couple of examples. Hitachi are in talks with LNER to replace an Azuma diesel power pack for trains that go relatively short distances off the wire, like the service to Lincoln. And Viva Rail have got, which operate converted underground trains, which quite a niche market, but actually quite effective. And they've developed a concept of a fast charging system where specially cooled batteries can actually be recharged at a very high current in 7 minutes. And that has got maybe potential. But as of now, generally it's short stretches line that can really accommodate batteries. So if we summarise that and looked at where each type of traction fits in, there's two things that we need to consider. There's a net zero railway and there's a transition to it. And you can see up there, there's certainly no role for anything that's diesel. But on the transition, we have things like bimodes that can facilitate a rolling program. There's a huge amount of work that potentially could be done to lower emissions with dual fuel arrangements, such as the test that Grand Central are doing with our 180s. But essentially, what that shows, and it reflects the TDNS report conclusion, is that electricity is the main answer. One thing that we did in Rail Engineer before the TDNS report came out, we did our own analysis to try and work out how much electrification was required. And what we did for that was looked at the sort of type of services we've got. So if we look at passenger traffic and the type of lines we've got, what those routes are, what is the percentage of traffic on these unelectrified lines? These are the unelectrified lines, and what's the likely traction type? And whilst things like sort of rural and branch lines, which are ideal for hydrogen and batteries, are up there, you can see that they take a relatively low percentage of the total traffic. And then we've got to consider freight. Freight needs electric traction. Diesel traction can cope, but struggles, especially on the severe gradients on the West Coast Main Line. And one of the things that the Rail Freight Forum did a study some time ago is that it doesn't necessarily need a massive amount of electrification. Clearly, you need as much freight as possible electric powered, but a relatively small amount of electrification can actually significantly increase freight haulage. And that is something that clearly is an integral part of the TDNS, and it's one of the reasons why intermittent electrification is not a good idea. But one of the points, though, that does need to be stressed is that rail freight is a highly competitive business, and that the rail freight companies need to know there's a long-term plan if they're going to invest in electric rail locomotives. So we actually did our own version of TDS. This has been completely overtaken, it's got to be said, but it was quite gratifying to know that what we came up with was not far different from what the TDNS study came up with. But one of the things I've got to say is that, I mean, pretty much all I've been talking about here is the end game, and that's really the easy bit. The transition to that end game is massively complicated, not only in terms of how you sequence all the various projects that need to be done, but also other technologies, such as the dual fuel that I referred to, that could be used to decarbonise traction right now. And there's a number of things there that need to be considered as the traction decarbonisation network strategy is developed. And it's designed to be developed to accommodate an evolving situation. So let's conclude now, please. And just to conclude, net zero carbon on the rail network requires net zero carbon electricity. That's maybe a statement to the obvious, but we talk about net zero carbon. It's only net zero carbon if the electricity supply is net zero. A net zero rail network does require a large program of electrification. If that doesn't happen, we just aren't going to get there. And hopefully the industry will be able to sell that. Currently, it's not possible to say exactly how much is required and exactly how much we're going to need of each type of traction, because there's a lot of unknowns. But what is definitely the case is, as of right now, there are some clear, definite electrification requirements which we should be getting on with if we can. Hydrogen trains need to be deployed quite soon to gain operational experience, and they need to be deployed as a fleet, and that requires an investment, because you do need to invest in the train supply. And I know both Alstom and, in fact, the Hydroflex initiative are actually progressing that. But we mustn't lose sight with that, even though their contribution is relatively secondary. And we need interim measures to decarbonise existing trains, and that's not necessarily going to be cheap, but as I understand it, a lot of these measures can actually have quite a good rate of return. I think the dual fuel initiative on the 180s is talking about a rate of return in fuel savings over about 3, 4, 5 years. So if it has a good rate of return, let's hope we can get on with it. One of the measures in the Committee for Climate Change report is that the Treasury had to make sure that the right financial levers were in place to ensure that the net zero target would be achieved, to encourage the right sort of investment. And I think were those levers in place, it would make the case for rail electrification even more overwhelming. And finally, and perhaps most importantly, the industry has got to educate decision makers. Clearly, from comments made at the Transport Select Committee, there is lack of understanding by politicians on some of the basic issues. I wouldn't for 1 minute criticise politicians for that. Politicians are hugely busy people with a huge range of activities issues to consider. The industry perhaps needs to make sure its messaging is a bit more focused. So, to conclude, what is the Judicious mix? It is lots of electrification, some hydrogen, some matters. Nobody knows exactly what that mix is going to be, but let's get started and find out. And thanks for listening.
David, thank you very much for a fascinating talk. It's clearly sparked a lot of interest, and we've got loads of questions to try and get through. So if you're happy, let's get cracking. I've tried to group them into some themes. So I think there was a couple of questions which relate to your conclusion 7 about educating decision makers. So there was an interesting question about do you think it would be helpful for representatives from Transport Scotland to actually speak to the Transport Select Committee? And how do we get these conversations happening?
I think it would be helpful. I would imagine that there is some dialogue. It certainly would. I think it would be very helpful. I mean, one of the problems perhaps is that when you're at a select committee and it's a fairly formal situation, it's not maybe quite as effective a way of communication as if you can do so informally. But certainly I think anything that can be done to informally get across the basic messages about the huge inherent benefits of electrification, and more importantly to try and get away from this message that innovation can sort everything. Clearly there's a huge role for innovation, but I actually think it's potentially damaging if we give the impression that innovation can do more than it is actually possible, that it can actually possibly do.
Okay. So do you think that there is generally there was a question here about whether there's a negative perception and some of the headlines that followed the Transport Select Committee meeting? And did you have any thoughts on what could be done to sort of change this perception?
I think it's the same question, really. There was only one negative headline I saw. I hope there weren't more than one. But the point is that question wouldn't have been raised if the MP concerned had been aware of the issues. His concern was, he quoted diesel, diesel was being pushed as the ideal solution for cars 20 years ago, so could electrification be the wrong solution? And how can we say electrification is future-proof? And David Clark from the Railway Industry Association gave a good answer, but it's quite difficult to convince somebody in a forum like that when they've clearly got an underlying concern in their mind. But I think somehow we need to get the message across, because I think it's utterly crucial that there's a clear focus message. I think as a report, the Transport Decarbonisation Network Strategy was a good focused report. It did say a bit in it about how different forms of traction worked, but I think just getting across the very key message as to why electrification is such a good thing is something we need to work on. And one of the things that perhaps we as professionals are not aware of, some of the things strike us all as maybe blindingly obvious, but they're not necessarily blindingly obvious. For example, the issue about, I heard one of Chris Grayling's advisors say electrification's okay for high-speed trains, but you don't need it on low-speed routes. And there was no understanding of the importance of acceleration. Now, I wouldn't criticise people for that. I think we need to get that message across. We would see it as pretty bloody obvious, but it's not necessarily obvious, and I think it's important to try and get simple, clear messages across.
Yeah, get the basics right first. So kind of moving on from the politics side to, I guess there was a big part of this is the electrification, and there was a couple of questions around that. The first was around capacity within the grid to actually support the large-scale electrification that would be required. And the second question, which you kind of alluded to, that we don't really know the answer to this but what do you have a feel for what the percentage of the judicious mix will be electrification?
In terms of the amount of traffic carried, I suspect it's something in the order of about 90%. In terms of actual kilometres of wiring, I think it's something of the order of about 75, 80%. I've not quite done the sums.
Okay. And what about sort of the capacity within the UK's national grid to support large-scale electrification? Do they? I mean, they must have to work hand in hand.
Well, I mean, if you think in terms of electrification, in terms of the bigger scale encompassing road transport and such like, then essentially the government is going to have to dramatically increase generating capacity in accordance with the Committee for Climate Change recommendations. As far as the railway is concerned, because we're only a relatively small user, if we actually increase the amount of electric trains that we're operating by 50%, which is really what we're saying, then I guess that's a 50% increase on what we use. I would expect, you would like to think the national grid could accommodate that, and it is all about long-term planning to make sure that that's possible. So I wouldn't have thought that was an issue, but who knows?
Okay. There's a couple of questions around the renewables. When it comes to obviously getting with electrification, the energy has to come from a green source. Is there any is it worth exploring connecting renewable energy generation to the electrification directly, or is it all part of the?
That's a good question. There's a company called Riding Sunbeams who are looking at just that. I'm sure if you Google Riding Sunbeams, and it's a study they're doing on the Welsh Valley lines, and they've looked to see, I think it's what solar power is available within 1 kilometre and what wind power is available within 2 kilometres, and how you can connect it up. And their conclusion was you could do that and you can make a lot of savings, because the nature of things at present is that there are some quite high costs for grid connections. And in fact, as I understand it, HS2 in their long-term projections for their power supplies is looking at a lot of directly connected electricity to the grid. But to make it work, apparently, one of the things that you actually need is a suitable three-phase to one single-phase converter, and there isn't such a thing at the right sort of power level at the right price range right now. And the other thing that I think was an issue from that report was that to make it cost effective, you've got to be able to feed the energy back into the grid when it's not needed, and there's questions as to whether Network Rail's license conditions allows it to do that, but you would like to think that that's something that could be resolved.
Yeah, okay. That's really great initiative. Yeah, there's a couple of interesting points raised around, which I don't think was mentioned in the presentation, around ammonia. And there's a couple of people have suggested there's some innovation within other industries of marine about using ammonia as a fuel, as a replacement for diesel. Is that something that that should be considered?
Maybe. Ammonia is certainly being considered for use on ships, but you tend to have a lot of space on a ship. I mean, a train is a very tightly constrained thing. You need to store the ammonia as a liquid to get the necessary energy density, and you need the plant to actually manage that. Ammonia is a highly poisonous chemical. I suspect that it's one of these things that might theoretically work. I suspect the practicalities of it as such, you're just better to compress the hydrogen gas. But it's for something like a ship where you have a lot of big space and you can accommodate all that plant easily. I think ammonia is probably a good net zero solution for shipping. Yeah.
There's no one size fits all, is there, for the different transport modes?
Yeah, I mean, I think trains are actually very constrained, and UK gauge trains constrained even more. And yeah, that's another argument for electrification, because with electrification, of course, you've not got that much kit that you need to actually package on the train. But if you've got to have a power plant of some sort on the train, then essentially it's going to take up space.
Yeah. Okay. Thank you. Yeah, we've got a lot of questions. So apologies if we don't get a chance to answer your question, but we'll try and get through as many as possible. In terms of there's a question around retrofitting existing DMUs, and I think there's a couple of examples of that at the moment, whether that's retrofitting with cleaner fuels or replacing with batteries. Do you see that as being a precursor to the electrification?
Absolutely, because electrification is a long-term project. One particularly worthwhile initiative, I think, Angel Trains are fitting, is it a 165 on Chiltern, to make it a hybrid, and also which would operate pretty much like a car battery hybrid, but with the additional option to work only in battery power at stations in a way that would be geo-fenced with GPS and such like. That is actually a very worthwhile initiative. I suppose a lot of these things, it comes down to a matter of cost. Clearly, you'll get some fuel savings from that, but it's also an expensive thing to do. So whether, I've no idea what the investment case is, but in the case of Chiltern trains, it could well become unacceptable to have diesel-powered trains going into Marylebone. Speaking from Scotland, I'm not certain on this, but I think that Marylebone is about the only station in Terminus in London where you have essentially a full diesel service now. And I would imagine that that could become, frankly, unacceptable in about 5 or 10 years. So we're probably going to be forced to do it.
Yeah. Yeah, that's a good point. So I guess there's a kind of leads us on to one of the other topics that's being talked about in the questions, which is around sort of the existing vehicles that we've got that are diesel. And got a question asked here: how do we decarbonise and cascade the numerous older diesel DMUs in the UK without a phased electrification programme?
Well, yeah, I mean, dual fuel is one option for fuel savings. It's a question of what's the life in those DMUs and whether it's worth spending money on them. It's quite a complex issue, really, as to when you're going to replace things. Some of the things will probably not get changed, but there is scope to make things more fuel efficient with things like the dual fuel initiative.
Yeah, yeah, and do you think a lot of our freight is diesel at the moment? So is that the dual fuel the answer for freight as well?
I can't see that. Well, it might be, yeah. Certainly, it's an answer in terms of emission savings. It's probably not an answer in terms of CO. It's certainly not an answer in terms of CO2. And freight needs electric to actually give it the power to fit in with the rest of the infrastructure. I would like to see if there was, for example, I'd like to see a comparison between how many train paths a diesel freight train soaks up on the West Coast Main Line compared with an electric freight train.
Yeah, okay. Question here, do manufacturers know what standards they will need to work to for traction batteries and onboard hybrid hydrogen storage?
I think the short answer to that is no. And I think that's an issue. I think some work's being done on that. I mean, I am sure Alstom have developed their briefs, and as I understand it, they have a proposal that's almost ready to go if the investment money is forthcoming. So I would expect that Alstom have actually done a lot of work on the actual approval process for that. But for new entrants into the market, it's more difficult. And I don't think there's any standards out there. You can use the common safety method and such like to try and get safety approvals for individual bits, but I think it's an area that the industry needs to work on, and I think that's actually being done.
That's good to hear. Yeah, that's clearly needed if we're going to shift towards hydrogen and battery. There's a question here asks, do you think hydrogen might lead to a return of loco-hauled passenger trains in a push-pull form?
I don't see that. I don't understand the rationale for that. I think multiple unit trains will be hydrogen will be deployed on multiple unit trains. I'm pretty sure of that.
Yeah, there's a reason for the why that concept has come about from the manufacturers. Clearly works. When you refer to electrification of the railways, is there a difference in energy consumption in comparing overhead line with third rail? And how does the cost sit with this for installing each system? I don't know if you've looked into that.
Well, it depends to a certain extent on the service, but you've got far more losses on DC. So I mean, DC is what it is, and it exists, and changing it to AC is not really a credible scenario. You've got far fewer losses on high voltage, and you can transmit more power with it as well. So, you know, third rail was good in its day, but it's not really a credible modern system. But we have to continue to use it for historical reasons.
Yeah. I can't see us getting overhead line on the London Underground anytime soon.
Nope.
We'll have to stick with third and fourth rail. It's quite a specific question relating to Scotland here. What is the optimum solution for the long rural branches in northwest Scotland that aren't economical for electrification and require a lot of onboard energy usage?
Interestingly, in NEWA, the traction decarbonisation strategy for Scotland doesn't specify battery and it doesn't specify hydrogen. It just says an alternative fuel. Certainly, they're suitable for hydrogen. If you could accept a sort of 10-minute stop every now and then, you could possibly use Viva Rail's fast charging system. My personal view is I think that they are probably quite suitable for hydrogen trains in the sense that hydrogen trains need to get fueled on pretty much a daily basis, but you could organise your fleet to operate from one strategically placed depot to do that. So my guess is hydrogen, but I've not got any inside knowledge.
Mm-hmm. Okay. So has there been any consideration of substitute fuels like HVO?
Like what, sorry?
HVO?
I confess I've not heard of HVO.
Hydro-treated vegetable oil.
Biofuels.
That's biodiesels. Yeah, biodiesels.
The Committee for Climate Change report is a bit sceptical about biofuels because A, they need a lot of, if you use them en masse, you need a lot of land to do that, which is probably better used for growing food. And also it needs quite a carbon input to produce them. So I don't perceive that biofuels are that credible an option. And if they were, they would be quite rare, and probably priority might be given them to use them in sectors like aviation, where there isn't any real alternative, whereas we do actually have other credible alternatives to decarbonise on rail. In fact, it's worth stating that, one of the things I should perhaps have said, that the transport sector emits a huge amount of CO2. Rail is the only sector where there is really an easy, credible solution for high-powered applications in the form of railway electrification. There's not a straightforward solution for HGVs, and even cars. There is a solution for cars for shortish distances, but not necessarily long distances. Rail offers a very technically easy decarbonisation solution in the form of electrification.
Okay. You compared the sort of UK's electrification programme with Germany's. Are there any other countries engaged in large-scale electrification, and how do they compare?
Well, I mean, looking at the slide I put up that shows how other railways compare in terms of their energy use, most of the railways have most of their heavy traffic under the wires, I would say. I think in terms of big electrification programs overseas, it's not something I'm fully aware of. I think Indian Railways have got a big scheme. I know Russian railways have got some lines that they're going to electrify to add to what they've got, but it's not something I've got a huge in-depth knowledge about, I must confess.
No, that's fine, thank you. Do you think that the progress that we're making in the planning for decarbonisation has been affected by COVID in terms of its progress?
It must have, because apart from anything else, I mean, the competition for funding is now huge and much more difficult than it was. So clearly it's got an impact, but the decarbonisation issue isn't going to go away, and it is a very hot political topic. So it will still be seen as a priority, but clearly in terms of things like getting approval for a railway electrification programme, it's going to be more difficult to convince the government, the Treasury, that we should be going down there.
Yeah. Just to follow up on the previous point, one of our audience members has highlighted that Indian Railways is planning to electrify about the equivalent of the entire UK network each year. So
yeah. No, it's a big railway, but yeah, that's good to see.
Yeah. An interesting question. I'm not sure what your views would be on this, but do we need to encourage more railway engineers to stand for Parliament?
Why not? I mean, certainly you get the perception that we have many more professional politicians now than maybe 30 years ago, when essentially politicians came from all walks of life. But having said that, I think, politicians are there, they're trying to do a good job, or most of them, I believe, certainly are. And it's our job, if the industry wants to convince politicians that something needs to be done, I think we need to try to convince them in the best way possible. From what I have seen in terms of some of the messaging, I think we've not given a good message as to exactly why the industry is asking for electrification, as I think was evidenced at the Transport Select Committee. And hopefully there's lessons to be learned from that.
Yeah. This is an interesting suggestion from one of the members of the audience, that he suggests that so all of the issues for rail freight also apply to heavy goods vehicles, and he wondered if you would agree that we should stop all the infighting between road and rail silos and work together to maximise the modal shift and the beneficial opportunities for decarbonisation of freight.
I can't really comment on that. I mean, it's a commercial business's freight, so the road hauliers are in business to make money. The rail freight companies are. If there are opportunities to form a collaboration to actually encourage modal shift, that's great. But I think you've got to look at the commercial incentives that people have got, and I'm not sure you can plan it. I think actually what would really help the freight industry, the rail freight industry, is an electrified railway, because you would be able to offer a better, more reliable service without getting in the way of passenger trains so much as well.
Yeah. Okay. This one's rather specific. I don't know if you know the answer to this, but it's around the fast charge example that you gave from Viva Rail. And do you have any details on the capacity of the electricity supply that's needed for those fast charge locations?
Yeah, the way it works is that the the fast charge locations have got quite a large battery bank. So you don't need a big electricity supply. You just have a large bank of batteries that's being on trickle charge, so that they can actually dump their full charge in the space of a short period of time. And the actual battery size, the actual size of those batteries, depends entirely on the nature of the service, frequency of service, and how many trains you're going to have to charge.
Mm-hmm. Thank you. I think we've got one last question before we wrap up tonight. This is around the hydrogen train concepts that are out at the moment, and what are the safety considerations that have to be considered with storing hydrogen on the roof of the trains?
Well, I mean, I would say that the chemical industry is well practiced in storing hydrogen. Hydrogen is lighter than air, as we all know, so if it's on the roof of the train, it's just going to go into the atmosphere. I think the hydrogen, clearly there are issues that you have to address, but I don't think that they're actually that much different from storing diesel on trains. Sadly, we saw a train crash recently when there was a fireball when a train crashed, because the diesel was atomized. And in fact, arguably, in that situation, had that train been hydrogen powered, there wouldn't have been a fireball because the gas would have all just gone straight up in the air. So it's a new technology, but I suspect that the risks and the issues are not that much different from what we've already got.
Yeah. Well, David, thank you so much for persevering and answering all those fantastic questions from our audience. I'd like to ask Richard McLean if he could give the vote of thanks.
It'd be my pleasure. David, an absolutely wonderful presentation, comprehensive, supported by facts and extensive knowledge. One thing I have to say is it's fantastically uplifting to be able to talk about something progressive, about the future, and not wallow further in the current COVID crisis, because this is a topic that is absolutely key, not just to but for society in general. And it's very interesting to observe how every sector is getting to grips with this right now. We've to shipping, and we've seen aviation, and even Formula One looking at how they can decarbonize their operation. I noticed that Formula One is promising for their shift. I think David confirmed to all of us as inmates of the rail asylum that electrification is indeed our secret weapon. But he also confirmed that implementation has been slow, sporadic, capital-intensive, and that we've not yet demonstrated to the people who have the checkbook that we're match fit and can be trusted with such an extensive investment program. He highlighted that the traction decarbonisation network strategy gives us a very good picture of the end state we've got to head for. But he poses, I think, the very meaningful questions of what we do in the meantime and what is our bridge to that end state. And I think he showed us the way. Find out how to deliver cost-effective electrification in a way that inspires confidence. We have to get rid of our and we have to learn from Scotland. Most of all, we need to get our passengers back after COVID and develop a comprehensive fleet transition to match that infrastructure, both to deal with the existing fleet to explore uses of alternative fuels, but to actually get some hybrid new build rolling stock in the shop. Because for those of you, I'm sure, who are out there looking for strategies to deal with your Class 150s and 165s, there is nothing to buy at the moment, even if there was money. The very big question of what we do with freight. I'm not entirely sure, David, that we'll see wires up in where they're going to pick up roadstone. So some interesting solutions will need to be found to keep freight cost effective and decarbonised. But a very, very big challenge, and one that I know is absolutely central to the role of this institution and of this division, is to educate and the decision makers. I think there was a lot of focus in on politicians, officials at the Department for Transport. Actually, as rolling stock engineers, I think we have to do a job of work explaining extra complexities that come with operational environments to our infrastructure manager and to other parts of our own industry. Now, in normal circumstances, I'd be asking you now to thank David in the normal way, a round of applause, but there may be people where you're all sitting in your sheds or in the corners of rooms who look a bit strangely at you if you suddenly started clapping. So I'll take it as read, David, that the audience is giving you a round of applause as we speak. My thanks on their behalf for an excellent and thought-provoking talk.
Thanks, Richard.
And David, on behalf of the South East Centre and North East Centre, thank you very much for your time this evening. Richard, thank you very much for your vote of thanks. I'd like to thank everyone who attended tonight and engaged in tonight's presentation with your excellent questions and participating in our earlier poll. It would be great if you could join us in our Zoom after party. Hopefully you have now been given a Zoom link which you can use to join us to continue the conversation, network, and have a discussion with new and existing colleagues and contacts. So I hope to see you in the Zoom meeting. But if not, thank you very much for your attention. Thank you very much for listening, and we'll see you at the next event. Thank you very much.